Hi multi-class. Can you believe it? I did a video so I wouldn't have to worry about time. That's crazy. I'm so smart. Anyways, I'm Vivian and I'm going to teach you how to do washer and shell method with an example because I think that's the best way to learn. Okay, so say we have this example here. Find the area between y equals sine x, y equals square root x, and x equals 2 rotated around y equals 1. Or y equals -1, I mean. And you know, that's a lot of words, so the first step should always be to draw the graph out. So it looks a little something like this, which I did on Desmos, but you can do it on your graphing calculator, because usually they're allowed for these types of problems. So you can see this is the line that you're rotating around, so this is y equals -1, and then this is the area you're supposed to find. And this top graph is y equals square root x, and this bottom graph is sine x. So as you can see, sine x is smaller than square root x, and that will be important later, but right now, let's just start with the top graph. So as you can see here, I have the y equals square root x graph, and when you rotate it around, you have this height, which is the same as this height over here, rotated around the axis as the radius of one of these little discs, which is why it's called disk or washer method. Right, so imagine that little height that I highlighted in aqua is this right here, right? So imagine that the y equals square root x is going over this. So you would rotate it around the y minus 1 axis, so it would rotate this way into this type of circle, right? So as you can see, this is around, or it is the radius, I just cut it badly, but this is the radius, and you know how to find the area of a circle. It's just radius squared times pi, right? But this isn't actually a circle because we don't live in 2D, we live in 3D, so there's actually this minuscule little thickness, this paper thickness, which is your dx. Okay, so now we have identified the equation for our integral because it's just all these little cylinders stacked on top of each other, right? So it would be the equation of the cylinder, which is the radius times pi squared, it's radius squared times pi times the dx over here, right? And the dx is this tiny little height, right? So first let's identify a and b because you're choosing the bounds of your integral, like how much you want to rotate it. So in our problem it tells us that this is x equals 2, and we know that y equals square root x can only be positive, so you're never going to go past 0, so the bounds will be 0 to 2, right? And then the harder part would be identifying r, right? So that would be this little area right here, or not area, sorry, this little height right here, like these heights, plus this height right here, and as you can see, this is a rectangle, so this is always constant. It's rotated around y equals -1, so this area right here is 1, and then this area right here is y equals square root x, right? So it would just be r x equals the height, which is square root x plus this little area right here, right? So 1. And then how do you know if it's x, right? Because sometimes it's y. In this case, it's asking you to rotate it around a horizontal line. So when you have a graph and you have a horizontal line, you're taking each dx like this way. So you would do it dx because you're progressing along the x-axis. If it were to ask you to do like a vertical line like this, then you would be progressing along the y-axis, so this would actually be dy instead. But right now, we're doing it horizontal, so it would be in terms of x. Yeah, so the finished equation for this top graph would look like this, right? Okay, yeah, so we figured out the top part equation for the larger graph, and for the smaller graph, it's literally the exact same thing, where you find the radius equation, which is, again, just y plus 1, and y is sine x, so sine x plus 1 squared pi dx, exact same bounds and everything. This is r x, this is pi, and this is dx. So you can take the two and minus them because this is the inside volume, so it's basically just acting like a hole to this outside volume. So you can just take those two equations and minus them to get this final setup right here, right? So you might be asking yourself, how do I even approach this large integral? And the answer is you put it in your calculator, because I'm teaching you washer, not how to do calculus. Once you have this set up, it's basically done, and as long as you know calculus and or have your graphing calculator, should be good. So the answer is 5.497. Once you have this set up, you're practically done. Wow, guys, that problem was so easy. It was light work. It was nothing. Okay, it was so easy. You've been enlightened. You're learning so much. But rundown to washer method is basically first step. Always first step is you should draw the graph out, right? It'll help you visualize. It'll help you do everything. It's where it starts, right? Next step, use that graph to identify the bounds. Sometimes it won't give you like exactly the bounds, and it'll just like tell you like the two graphs like intersect, and you need to find where that graph intersects, or it intersects with the x-axis, I think, or x or y-axis. Those are the two common types of problems. So use algebra, find the intersection point, and identify the bounds, right? And then find the radius. Just this is where drawing it out will really help you, because you can see like if you should ever add or minus things, because usually it's pretty easy and it's just around the x or y axis, but sometimes if it has like y equals -1 or like x equals 2 or some weird value, then you should really be careful, because sometimes people add, minus, do it wrong, so be careful about that. Yeah. And then just put it all together into that same equation of the integral, where it's the equation of r in terms of either x or y multiplied by dx, which is the thickness, and pi, right? And then r is squared. Okay, so let's try shell now that we finished washer. So here's the question. Find the volume between y equals square root of x and y equals 1 over 2x rotated about x over equals 3. So we can start with our exact same process where we draw it out first. And we first draw it out, right? And then we identify the bounds a and b, and then we set up our equation, which is 2 pi hy py multiplied by dy. So I have that all labeled here. Okay, so we're back with this example. Imagine this is the little aqua height that I had highlighted. Turn it 90 degrees, rotate it around, and it makes something like this, right? This ring, where the length of this ring this way is the length of the height, and the distance from, or like the radius, is the py value, right? So when you unfold this ring, it turns out just to be a rectangle, right? And as we already established, this is the height, and so all we need to do is have the height multiplied by this top edge, right? And this top edge is just the circumference of this circle, which we already established the radius of, and the circumference equation is 2 pi radius. And if radius is py in terms of y, then we know that this, or like the area of this, is the rectangle. So height in terms of y, p in terms of y, and the little thickness that we established before, so multiplied by dy. Okay, so because we are integrating here through this area this way, parallel to the axis of rotation, everything is in terms of y, right? So we need to convert these two equations into terms of y, right? We need to make them like pluggable into this integral. So as well as the equations hy and py, we also need to make a and b the y coordinates this time. So if we look at the sketch that we have drawn, we can tell that we are integrating from 0 to 2, and 0 is pretty self-explanatory. You can't go below 0 with a square root. It's always positive. And this 2 is the intersection between y equals 1 over 2x and y equals square root x. So you just set them equal to each other, and then you just get x equals 2. Basic algebra. So we have 0 to 2, and then we have our mandatory 2 pi, and then to identify height, we need to find the distance between this graph and this graph. Sorry, let me get the pointer. This graph and this graph, right? So we already put it in terms of y, so that's really all we need, and we can tell that the y equals 1 over 2x is larger than the y equals square root of x, so we will have that as the minus to find the difference, right? So 1 over 2x, or sorry, we need to put it in terms of y, so 2y minus y squared multiplied by this py value, which is, as you can see, the axis of rotation is above the shaded area, so it would be 3 minus our y value, right? So 3 minus y, and then our dy. And this would be our finished integral. Okay guys, so here are some parting questions that you should really try on your own. I have answers written, do both washer and shell. It's always good to do both on the test and as practice, so you can, check your answers and maybe catch any mistakes you would have made with one of the methods. Remember, graph, identify bounds, then equations. Washer is when you're integrating perpendicular to your horizontal, or not to your horizontal axis, your axis of rotation, and shell is when you're integrating parallel to your axis of rotation. And y and x, the terms, depends on that axis of rotation and whether it is vertical or horizontal, and which method you are using for it.